How many different ways can we spell abracadabra in this formation? Here are the rules. We start at the A at the top, and we have to go downward every time. So for example, this is a valid path. Abracadabra. And here's another path. Now the question is, how many different paths are there? Let's find out, but first, make an estimate. Now, if we try a couple different paths, one may notice that in all of our paths, in total we are going to the left 5 times, and we are going to the right 5 times. Here was our other path. We went to the left 5 times, and we went to the right 5 times. So we're essentially asking, how many different ways can we place 5 lefts and 5 rights in a row? To make this easier for us, I'm going to make sure that all of these lefts are distinguishable from each other, and I'm going to do the same thing with the rights. So I'm going to write them in a different color. So now it looks like we have 10 unique elements. How many options are there for the first position? 10. Then after one element is placed, there are 9 options for the second position, 8 options for the third position, and so forth. So if we multiply 10 times 9 times 8 all the way down to 1, we get 10 factorial, or 3,628,800. Now, that's how many different ways we can arrange these, assuming that they are all unique, but they are not. Originally, we're just working with 5 lefts and 5 rights, so we need to divide by something. For example, if we switch the 2 L's in positions 4 and 5, no one would notice and no one would care, but they are counted as unique over here. So how do we figure out what to divide by? Well, let's focus on the lefts first. Let's say that they have to stay in positions 3, 4, 5, 7, and 10, but we can arrange them as much as we want. How many different ways can we arrange them? Well, if we go left to right, there are 5 options for position 3, 4 options for position 4, 3 options for position 5, 2 options for position 7, and 1 option for position 10. So 5 times 4 times 3 times 2 times 1 different positions, or 5 factorial, or 120. So over here, every group of 5 factorial, or 120, count as 1, because no matter where the 5 L's are, there are 120 different ways we can arrange those 5 L's in those same 5 positions. And it's the same story with the 5 rights. No matter where they are, there are 5 factorial, or 120 different ways we can arrange 5 rights in any given 5 positions. So we have to divide 10 factorial by 5 factorial twice, and some may know this as 10 choose 5. And when we divide, we get 252. So there are 252 paths that spell abracadabra. So how close was your estimate? Let me know in the comments.